Alright, welcome back. Relax, concentrate, and let's learn. Alright, so in the last video, we discussed different ways of thinking about functions, different ways we could represent functions, or that process of mapping and relating inputs to outputs. We'll be using some of those representations in this video. Alright, and we also concluded in the last video that a function is a kind of relation. Why do I say kind? Because relations, they do map inputs to output by a rule. They're just like functions, but we classify functions as a kind of relation. Not all relations are functions. We'll see how in this video, and from another perspective in another video. So let's start.
I'll repeat what I said in the previous clip, which is that relations do what functions do. So a function is a relation. That's correct. Okay, so relation maps inputs to outputs. All right, so a function is a relation. However, not all relations are function. There's a difference there, and we're going to find that difference and then go into types of functions. Two main types of functions. All right, first of all, the main thing to know, or the main difference between a function and a relation, is that a function has its inputs related to just one output for each input. All right, I'm going to rephrase that. Basically means that for every input, there's just one output, no more than that. Examples are coming later in the video. So now the two main types of functions are the first, one-to-one function. For a function to be classified as one-to-one, every output has to be related to at most one input. For example, here, 2 is related to the input 1 in the set x, which is at most 1. 4 is related to 2, that's just 1. 6 is related to 3, that's just one input that output is related to. Alright, if 2 was related to more than one input, then it wouldn't be one-to-one. Again, there is going to be a clear example later in the video. Now, the second type of function is the onto function. And for a function to be classified as onto, every output has to have at least one input that it is assigned to or related to. For example, here, this function is onto. Now, it may look confusing, but it's onto because every output, well, we only have one here, so the output is related to at least one input, actually 2, but that's no problem. But this can't be a one-to-one, because for a function to be one-to-one, an output has to be related to at most one input, no more than that. But here we have more than one input that this 2, the output, is related to. And here we have 3 to 6. 6 is an output which is related to 3, and now we know every output has at least one input, and so it's an onto function. Alright, one-to-one and onto. Let's go into some more examples about that, and then we will return to what I said in the beginning of the video, and then just another tiny touch or case about types of functions. Alright, one-to-one functions. Keyword at most 1. An output has to be related to at most one input. Let's call x the set of inputs, y outputs, and then let's say we have 1, 2, 3, 4, 5, 6, and let's say 1 maps to 4, 2 to 5, 3 to 6. We check the outputs. 4 at most 1, great. 5 related to at most 1. 6 related to at most 1, which is 3. So this is a one-to-one function. Alright, now let's take another example. Again, the same two sets, inputs and outputs, for some arbitrary function. And then let's say we have 1, 2, 3, 4, and 5. 3 to 5, 2 to 5, 1 to 4. 4 is related to 1, that's just one output, that's great. 5 is related to, oh, it's related to 3 and 2. That's 2 outputs, while for a function to be 1 to 1, an output has to be related to at most 1 output, while here we have this output 5 related to 2 inputs, which is bad. So this is not 1 to 1. Now the final case is here. Let's say we have 1, 2, 3, 4, 5, 6, 7. 3 to 5, 2 to 6, 1 to 4. 4, the output is related to just 1 input at most. 5 to 2, 6 to 3, 7. Nowhere to go. Or it's not being assigned to any input in the set of inputs X. Well, that's not a problem, because the definition of a one-to-one function just requires that every output is related to at most 1 input and no more than that, just like we have here. So 7 being left alone is fine. Alright, now onto. The keyword for onto functions is at least. Let's say again, we have our 2 sets here. 1, 2, 3, 4, 5, 6. At least. Every output has to be mapped, or related to, I should say, at least 1 input. Okay, how does that work? Let's say 1 to 4 again, 2 to 5, 3 to 6. Same example. 4 is related to at least 1. That's great. 5, at least 2. 6, at least 3. So this is onto. This is an easy example. Now let me demonstrate or give an example that shows why at least 1 input is important. Again, okay, so 1, 2, 3, 4, 5, 6, 7. 1 to 4, 2 to 3, 2 to 5, sorry, 3 to 6. This is great. It has at least 1. 5 has at least 1 input. 6 related to at least 1 input. 7, oh, well, that's left alone. While by definition, onto functions have their outputs related to at least 1 input. Here, 7 is not related to any input, so this is not onto. Alright. Now, we could write these as ordered pairs. Alright, so say we have this one-to-one function here, okay, with its output related to at most 1 input. Okay, how would we write this as ordered pairs? The set of ordered pairs would be 1, 4, the input is 1, output is 4, and so on. But we would leave alone this 7 over here. And this applies to onto functions as well. Now, let's return to what I said in the beginning. No single output can have more than 1 input for a relation to be a function, or a function to be really a function. Okay, let's take a quick example. Again, inputs, outputs. 1, 2, 3, 4, 5, 6. Just very simple, okay? 3 to 6, 2 to 5, 1 to 4. This is a function. Great. Why? Because the input is mapped to 1 output, input, 1 output, input, 1 output. Now, what if we had instead here a function or a relation? Okay, let's see if it is a function. 1, 2, 3, 4, 5. Let's say we had 6. Okay, let's say we had 3 to 6, 3 to 5, and 1 to 4. Just neglect this 2 over here. Let's say this is our relation. Is it a function? No, because essentially the function has to have its inputs mapped to no more than 1 output, while here we have an input that's mapped to more than 1 output. All right. So I hope you learned about the main difference between a function and a relation, and that functions are relations, but not all relations are functions. And I hope you understood types of functions. Now, if you have any questions or even suggestions about videos, find my email below. Please consider subscribing and sharing. Thank you.